So in this clip, we're going to discuss a few more saw terms that might make it a little bit easier as you go through the other videos. For this clip, we're looking at the side of your saw blade on a really close-up view. This is the actual carbide tip, this whole portion here. This is the shoulder, or the steel part of your saw body. All this down here is all steel that the saw tip is brazed into. Okay? So this is the tooth, tip, this is the shoulder. The face of the tip would be right here. This area is the whole part here is the face. This whole area up here is the top of your tooth. When we sharpen your saw blades, typically we remove 3 to 4 thousandths of an inch off of the face of the tooth and 6 to 8 thousandths off the top of the tip. Let me draw something in here. Let's say there's wear on your saw blade and it's worn right down to there. If I were to take all that off the top of the tooth, I'd have to come down this far off the top. We don't just do that. There are some companies that only top grind. There's other companies that only face grind, and they'd have to remove that much of the saw tip to get your saw blade sharp. We face and top grind, so we leave as much tip as possible. And it's really hard to draw on the scale that I'm doing right now, but by facing and topping, we'll get probably 15 to 20 sharpenings for you out of your saw blades out of a standard carbide tip. And you get the sharpest cutting edge possible by doing that. We will expose new tip itself on the face and the top. It gives you the longest life and the sharpest cutting edge. This portion down here is critical. This is called the gullet. At the bottom of your sawtooth, as this blade is cutting material, the chips are being funneled down into the gullet. When the saw blade exits the cut on the bottom, it dumps or ejects all that material out. That's very important for keeping the saw blade cool. A cool saw blade stays flat. As steel or the body of your saw blade absorbs heat, it's going to start to wobble. We want to keep that as cool as possible. So we want the sharpest cutting edges and a nice big gullet to throw those chips out of the way. Right now, I'd like to get a little bit deeper into saw science than you probably ever wanted to get into, but I think you're going to be happy that you watch this clip, because you'll find out why your cuts are really smooth. For any of you woodworkers that are wanting to do glue joint rips, or if you're cutting corian and you want perfect joints, or if you're cutting a piece of plastic and you've been having melting issues, I think this clip is going to really help you. For this clip, the picture that I've drawn on the board, this is your saw blade. It's like it's spinning directly towards you. The face of the tooth is now coming directly at you, like you're the material, and then that's the view that I've drawn on the board behind me. This is a close-up, whether it's the best rendering that I could do freehand, of the saw blade coming directly at you. This is the face of the carbide tooth. This is the top of the tooth. This is a straight top saw blade. This is the plate, or the body of your saw blade. Your arbor would be down at the bottom of the picture. Now, carbide saw blades are made different than steel saw blades used to be. Steel saw blades used to have the body of the saw, then the teeth used to be set left and right. That's called set. On a carbide blade, they're much, much more accurate, because we want a saw plate that's been smithed perfectly flat, and then the sides of the teeth have been ground with built-in clearance angles. When your saw blade is manufactured, it has a built-in top clearance angle, which I have to draw a different view for that. It has a built-in side clearance over here. That's the distance from the top of the carbide tip to the saw plate itself. That's what side clearance is. So we would take an indicator, we would measure from the top corner here to the plate. Then this particular blade, the way I've drawn it, has a 30 thousandth side clearance. All right? Then there's another angle called radial clearance, which is super important when we're looking at the finish of your cut. Radial clearance is determined if you take an indicator and measure from the exact corner of this tooth. For this illustration, it's 30 thousandths of an inch. And then you come down to the bottom of your tooth, which we have 25,000 side clearance. So we've got 30,000 side clearance minus 25,000 side clearance. That gives us 5 thousandths of an inch radial clearance, which is wonderful clearance for doing most woodworking. Now, Forgive, my hands are now the sides of your saw tip. And this would represent a saw blade that has high radial clearance, very far apart at the top, close into the bottom. That blade is going to cut very cool. If you're ripping a board and you want to get through the board and you want it to be a really easy push and you're not really concerned about your edge finish, you just want to get through it because you're going to joint it afterwards, you want a blade that has a lot of radial clearance. Also, if you're using a low horsepower saw or you're running on an extension cord and you keep popping your breaker, you want a high radial clearance saw blade. It's going to push very easy. Conversely, if I want a really smooth cut or a glue joint rip, I want low radial clearance. So I want the top of the tip to be almost the same kerf as the bottom of the tip. That is going to give you a mirror edge on the side of your wood. Actually, we've had to make saw blades a little bit higher radial. We've made saw blades cut so smooth that the glue doesn't want to adhere to it. It's too smooth of a cut. So you don't want no radial clearance and you don't want too much radial clearance. It has to be made for your application. And we can give you recommendations on what is the proper radial clearance for what you're doing. So that's why Brian and I will ask you a lot of questions as to what your application is, what machine are you using, how much horsepower do you have, what type of finish you're looking for. All those things help us give you the proper saw blade. Hi guys, in this clip I want to discuss the top clearance angle. This is the side of your saw blade still. The angle from the point of your tooth down back towards your shoulder from a straight like this is your clearance angle. Most saw blades use a 15-degree clearance angle in cutting wood. We have some very specialized clearance angles that we've tried over the years for different materials. But a good rule of thumb is if you're cutting a soft material, which wood would be a soft material compared to steel, let's say, we would use a clearance angle like this, a 15-degree clearance angle. The denser the material that you're cutting, if we're cutting aluminum, we're going to alter the clearance angle. If we're cutting brass, we're going to alter the clearance angle, all the way to steel. When you're cutting ferrous steels, and believe it or not, we sell a complete line of saw blades to cut ferrous metal with a carbide tip circular saw. We want a lower clearance angle. But just so you understand, this is what a clearance angle is. In this clip, I'd like to describe to you what kerf is, just so when we're talking on the phone, you know what it is. The kerf of your saw blade, if this is the saw plate, and this is the face, like the blade were coming directly at you, the kerf is the widest part of the sawtooth, which would be the very top corners. If the blade's made properly, it's the top corners. And that is the kerf of your saw blade. There's some good rule of thumbs. If your plate thickness is an 85 thousandths thick plate, then a standard kerf is an 1/8 inch kerf. If you have a 120 plate, 180 thousandths kerf is standard. There's some standards in the industry, but everybody does different things. Some of you guys need thin kerf saw blades. We have saw blades down to, I believe, 55 thousandths of an inch kerf. So the saw bodies are down around 35 thousandths. You know, very unique for very special applications. You might need a very heavy saw body. We had some customers cutting, they were an MDF plant, and they were cutting 8 inches thick MDF 24 hours a day. And we had to make some heavy saw bodies for them. And you know, they were getting up into the cutting hundreds of thousands of feet in a shift. So there's different requirements, but kerf is the maximum amount of material being removed in one rotation of your saw blade.